Hi, this is Miss Park. Today we're going to be finding the length of a line segment, or another way to say it is the distance between 2 points. So the length of this line segment AB that I've drawn is the same as the distance between point A and point B. And how are we going to find it? So let's pretend that this is sitting on a grid. And it's hard to figure out the length when the line is diagonal. If it was horizontal or vertical, we could count the boxes. But it's hard when the line is diagonal. So even without the grid, though, we know that to get from A to B, I'm going to have to rise and I'm going to have to run. Okay, and that's the same as when we calculated slope, we had to rise and we had to run. So how much do I rise from 3,1 to 6,9? So my y's are going from 1 to 9. So that means I am rising 8 units. And the way I do that is because if I want to end at 9 and I'm starting at 1, that difference is 8. And then for the x's, I'm starting at an x of 3 and I'm going to an x of 6. So that is a difference of 3 because I want to end at 6, I'm starting at 3, and so I have to move to the right 3 units. Okay, so how do I figure out the length of this? Right? If I redraw this for you, what we actually have is a right angle triangle. Okay, we have this right angle triangle where this is 8 and this is 3. And how do we figure out the hypotenuse of a right angle triangle if we know the lengths of the other two sides? So we have a relationship for this that is commonly known as the Pythagorean Theorem, even though it was discovered long before Pythagoras, but we call it this, and that's what it says in your textbook, Pythagorean Theorem. And it says if you square the lengths of the shorter sides and add that together, that will equal the square of the length of the longer side. The longer side is always the hypotenuse. So 3 squared plus 8 squared equals c squared, or whatever this question mark squared. 9 plus 64 equals c squared. 73 equals c squared. And so if c squared is 73, then to get just c, it's the square root of 73, right? And whatever that is, something with a decimal, but we will leave it as an exact number, square root of 73. And so therefore, AB is the square root of 73 units long, just using the Pythagorean theorem. Okay, now what if the numbers were a little bit messy? So there is a formula for the distance of a length of a line segment, or distance between 2 points, and it goes like this. Suppose my 2 points were not with numbers. Suppose they were like this. Here's A, x1, y1. Remember, we've seen those before. And there's B, x2, y2. I want to travel from A to B. So I've got to rise and I've got to run. Okay, and this is my little a, my Pythagorean theorem, little a and little b and little c. So little a squared plus little b squared plus little c squared is going to, little a squared plus little b squared is going to equal my little c squared. And little c is the length of AB. So that's where we're going to try and go. So what is my rise and what is my run? Let's see if we can do this. Along the y's, I'm going to go from y1 all the way up to y2. So that is going to be a difference of y2 minus y1. Remember before, we went from 1 all the way up to 9. So that was a difference of 8. That's rising 8. Here, I'm rising the difference of the y's. Right? Remember that rise is the difference in the y's, and the run is going to be the difference in the x's. I'm starting at x1. I want to go all the way to x2. So that means my difference is x1 minus x2 minus x1. Like in the other one up there, I was going all the way from 3 to 6. So the difference is 6 minus 3. All right, and so we have our relationship now, and I'm just going to write it a little bit differently. I'm going to write, instead of C from Pythagorean theorem, I'm going to write D for distance between 2 points. Or I could write it as this L, length of the line segment. It really doesn't matter. Okay, so let's use D. We know that D squared is equal to x2 minus x1 squared plus y2 minus y1 squared. That's Pythagorean theorem. Okay, and if I take the square root of both sides, because I want just the distance, I get that is the square root of x2 minus x1 squared plus y2 minus y1 squared. And that gives us a formula for the distance between 2 points. Okay, so let's do an example. Find the distance between the points, and let's throw in some negatives and make them all complicated. So go -1, 3, and let's call this point A, and we'll call this point B, 7, -10. Okay, and so let's find the distance. So we'll use the distance formula. All right, this is x1, y1, this is x2, y2. So the distance is the square root of the difference of the x's, all right, that's your run, and the difference of the y's to create Pythagorean theorem. And so that's going to be the square root of, so 7 minus -1 squared plus -10 minus 3 squared. And that's going to be 7 plus 1 squared plus -13 squared, which is 7 plus 1 is 8. 8 squared is 64. And -13 squared is 169. And that gives us the square root of, I'm going to grab my calculator, but you can do it in your head if you can. Okay, so I'm going to go 64 plus the square root of 169, plus 169, that's 233. So the distance between A and B, or we can call it the length of AB, is equal to the square root of 233 units. And whatever that square root happens to be, we don't really care. We'll just leave the answer as in the square root sign, because then it's exact and we're not approximating it. Unless the question specifically says to round it to a certain number of decimal places, we will always leave it as a square root. Okay, that's the length of a line segment formula, or distance between 2 points. Thank you.